It's such an incredible pleasure to have you here, and I'm embarrassed to have notes because you have no notes right now, but we have a little bit of some questions to ask, but I think we can maybe go. I think you're probably really comfortable going off script.
I've lived off script. I've
Right.
never had a script, so yes.
So how are we here? I remember during your confirmation hearing, we were listening to it, and someone said, he just talked about ending energy poverty in Africa. Like, this is a really good guy. And I had heard of you before, and I'd read a lot of the things that you had written when you were at Liberty Energy. You guys released the Better Human Lives report. I'm going to read a couple of the things that said. It said that energy is essential to life, and the world needs more of it. Hydrocarbons are essential to improving the wealth, health, and life opportunities for the less energized 7 billion who aspire to be among the world's lucky 1 billion, which you just talked about. So I'm not going to go through the whole list, but I would encourage everyone to go on that site and read that report because it's really outstanding. We're lucky to have someone who's an engineer, a business person who's worked across all the technologies because you get it, that it's a technology agnostic approach. You do what's best for the country, taking advantage of the resources that they have. And we need it's inexcusable that people don't have access to electricity. That's why I got back into this game after having done Power Africa for a number of years. I left, and then I'm like, I'm back doing it now with Mission 300. We're trying to do it at twice the speed that we were doing it before, trying to get 300 million people access to electricity.
Fantastic.
By 2030.
Fantastic.
And we need you as a partner because we can do this. I mean, as I describe it, it's a construction project, right? It costs money. You need the right people and the right expertise. So enough about me. Let's get straight into questions about you. So you've talked about the importance of ending energy poverty and advancing U.S. energy leadership. How does your vision for zero energy poverty by 2050 reshape how the U.S. engages Africa's energy future?
You know, the first is to stop digging the hole. Stop telling Africans what they can't do, what we won't finance, what we're not in favor of. Stop trying to insist this is the answer. We'll come do this in your country. So again, as Adam said, and I think as you've spoken, to be your partner, like it's a different. You're off-grid. Solar's awesome. Like as they said, there's no technologies I don't like. I don't have any blanket views. It's to partner with African nations and get commercial alignment of interest. There's all sorts of entrepreneurs in Africa and all sorts of entrepreneurial spirit that are held back by this lack of energy. How can we harness that entrepreneurial spirit with some technology assistance, lower cost capital from the United States to make things happen? I think since I don't believe in that, we don't have a top-down grand plan. It's going to work this way. We want to evolve and engage with Africans, find what works, double down on those.
I mean, the point that off-grid solar is awesome, but I think you and I would agree on this. You can't boil a pot of water from a small solar panel. So while you can get everybody electricity and charge mobile phones and cell phone, and charge your mobile phone and have basic lighting from a small panel, you're still going to be doing cooking with wood, biomass, charcoal. Can you talk a little bit about clean cooking and what you see us being able to do to try to address this issue?
Yeah, Andrew, before I go into clean cooking fuel, a lifelong passion of mine, let me just take a couple moments about energy. And I don't think it's true in this room, but in most rooms, people confuse energy with electricity. Like if we pave the world, the whole planet in a solar panel, we'll be 100% renewable. And my answer to that is electricity today, and the same is true in the United States, roughly 20% of global primary energy is delivered via the electricity grid. 20%. We use now talking about uses of energy. 25% is for transportation. 25% is for houses, businesses, homes, this conference, all this stuff. The biggest use of energy by far, and I would argue the most important use of energy, is manufacturing, making things. 20% of all global energy is used to make 4 materials: steel, cement, plastics, and fertilizer. The best energy scholar of our time, Vaclav Smil, calls these the 4 pillars of the modern world. There is no modern. I'm an electrical engineer, so what about silicon? And silicon's neat and it's important, not even close to as important as steel, cement, plastics, and fertilizer. 20% of all global energy is just to make those 4 substances. Africa's short in all of them. African farmers are less productive because they don't have enough fertilizer. Plastics, modern conveniences, they lower the cost of storing and transporting and doing everything. So we got to be sober about where energy comes from. And of course, for manufacturing, it comes from process heat. You have to combust something to get to high temperature. So we manufacture dominantly using wood, coal, oil, or natural gas. 15% of the energy in that manufacturing sector comes from electricity. Well, we're electrifying everything. Well, 25 years ago, 15% of the energy in manufacturing came from electricity, the same as today. So let's understand, energy is much more than electricity. Electricity is awesome. We want everyone to have it. It is life transformative, but just it's a piece of energy. To your point, Andrew, coming back to your question.
I mean, so it's a great point. It's one that got me in a little trouble when I was in government, because we're sitting in a meeting with National Security Council and people were looking at, why are food prices going up right now? And we looked at what are the key inputs of food prices. It was transport and it was fertilizer. And I said, has anyone considered that maybe the climate policy could be contributing to high food prices, given that fertilizer and transport are all driven by fossil fuels right now? Should we be doing so? That wasn't the appropriate comment to make, but it's spot on. Exactly.
But it's just the truth. Right. And that's my other thing too. Look, I worked, as I said, in a lot of energy sources. I never worked in coal. So if I was a businessman, I'd be against that one. That's market share competitor. But I've never felt that way. I've never acted that way. In fact, I spoke at a conference celebrating the shale revolution 15 years ago. And it was about, because of its reduction of greenhouse gases and all that. And I said, boy, and in a blind squirrel finds nut, I played a role starting the shale revolution. And I said, that's awesome. This is 15 years ago. I said, but if I was going to give the MVP of world energy over the last decade, coal wins in a landslide. Not even close. Gas is by far the fastest growing source of energy now, so it is becoming a growing force, but it's different energy in different places. And you came back to, I think, the biggest not talked about topic, clean cooking fuels. And I think Adam mentioned it as well. 2 billion people on our planet, don't have clean cooking fuels. They cook meals just the way all of our ancestors did only a few generations ago. So this is a recent modern change, but it's high intensity energy. As you've shown, you get maybe 1/10 as much energy out of a local solar system that you would need to cook something. And so that time saving, that clean, for me, my passion about it is to reduce indoor air pollution and save and extend lives. For most people that don't have access to clean, thank you. And that's our wealthy guys' perspective and gals' perspective, right? That's what we think about it. But for the people that are getting clean cooking fuels for the first time, the biggest issue for them isn't that. It's time. It's liberation. It's freedom.
I remember one of the things we did with Power Africa, I had this realization because people were saying, if you got an off-grid solar home system, you don't need anything else, you're good. And I said, that's not true. And I said, why don't we have LPG canisters going out to these places? And it was always had to do with the distribution network. So one of the things we did was we tried to see, all right, well, why don't we give an incentive to some of these solar home companies to partner with LPG companies so that people can live a modern energy lifestyle. They can get their lighting from solar, but they need to get their cooking from gas. Otherwise, we're going to be having the same conversation 40 years from now, and they may have light, but they're still going to be cooking with wood. So what should we be doing?
And you said a key thing there. I'm trying to get this company to partner with that company or to get into that business too. Business is the driver of social change. If it's a government program or it's a whatever, you can't point to a lot of successful transformations in society anywhere that wasn't driven by business. And the reason is, of course, business is voluntary exchange. You got a customer that wants the product and a businessman or businesswoman working their tails off to try to get the cost down and the quality up that it's worth to transact from the other side. So it's enabling local businesses in Africa. I think that will be the biggest force that will bring clean cooking fuels, that'll continue the efforts you've worked on to bring electricity to off-grid places, to bring fertilizers, to bring lower cost services, to better lives. And we've also gotten into a world where all these policies should be driven from above by the government, by the mandates, by the multi-gathering of the nations that come out with these truths from on high. Like, that's the opposite of how improvement is driven.
I mean, if you can get a Coca-Cola to a remote area, you can figure out how to get an LPG canister to a remote area, and that was kind of the theory that we had on that. All right, I'm going to turn to gas for a second. It was probably 8 years ago when I was interviewed by one of these African magazines asking what my prediction was going to be for the coming year. And I was being maybe a little bold. I said, I predict that we're going to see FSRUs all along the coasts of Africa, and we're going to bring in import gas while they build out their power generation and while they build out their the potential for their own gas that they have there. What do you see as the future of gas for Africa and what the potential is, if you have thoughts about how we should be thinking through that over the next few years?
So, and again, I can't help but give numbers. In the last 50 years, the growth for oil has grown a little over 1% compound annual growth rate for 50 years. And it's not slowing today. It's roughly the same compound annual growth rate as it was 50 years ago. Same is true for coal, a little over 2%. And natural gas is growing 3% compound annual growth rate. And the reason is oil is the most flexible, but it's the most expensive. Coal's cheaper, so it's growing twice as fast. And gas is starting from a smaller base, but ultimately can be very cheap. If you have pipeline gas in the United States, you produce it and you put it in a pipeline and you send it to your factory or your things, which we have in the United States, it's just an awesomely cheap resource, not just for cooking, but for heating, for producing fertilizer and petrochemicals and powering industries. But if you load it on a ship and send it overseas, it's much more expensive. It's still cheaper than oil. It can do a lot of the things oil can do at maybe half the price. And so that's why it's growing so fast. We send a lot of natural gas overseas in the United States, and that will grow massively. But I'm often asked, is that the answer to coal in Asia? It's going to be US LNG. No, the scale of coal in Asia is so much bigger than the scale of LNG. And when you put natural gas on a ship, it becomes much more expensive than coal, still cheaper than oil. So in China, they're powering their long-haul trucks on natural gas, cheaper than diesel. They're powering power plants in the city to reduce pollutants in the air quality, and they're powering factories. But is it going to be the backbone of electricity of China or India in the next 10 or 20 years? It's not. So in Africa, there's countries that have local gas reserves. You can produce that gas and put it in a pipeline to local communities and power plants, home run. If you can import LNG from the United States to coastal plants or whatever, also lower cost and other options. But from what little I know, and everyone in this room knows more than me, probably a lot of future electricity in Africa is going to come from coal, and should come from coal, because the resources are there, it's easier to transport, you need less infrastructure, and it's low-cost, affordable, reliable energy. And you can partner with the US for technologies to capture the particulate matter, the SOx, the mercury, the pollutants that harm human health. We have technologies pretty easily to do that. To capture the CO2, the greenhouse gas from coal, is very expensive and really isn't done at scale anywhere. Maybe that technology will get better, but that's a longer-term thing.
The carbon capture technology, are the prices coming down?
It's coming down from extremely high to very high. So look, that's a long ways away. But and to me, it's very important that we separate pollutants, which are toxic to humans and they hurt your health today, like indoor air pollution from burning wood, burning coal, burning oil, burning diesel in old engines. That creates pollutants. The smog you see in cities, that's very harmful to human health. With technologies, we're getting much better at that. That is separate from greenhouse gases. I think it's a huge misnomer when we call that carbon pollution or pollutants, not part of clean air. Like life on Earth, the three most important gases for life on Earth is water, oxygen, and carbon dioxide. There is no life without those. So it does absorb infrared radiation. It does have a side effect. But what's been the impact of 50% higher CO2 concentration atmospherically? Is increase in temperature, increase in sea levels, some pretty big negatives there. It's also making the planet greener and a little bit wetter. There's some pluses to it too. So we just got to be realistic about it. It's a real problem, but it's a problem we're likely going to solve over many generations. We're not going to do anything meaningful for it for 2050, and sacrificing price and availability of energy for incremental tweaks between now and 2050, I think has been sinister.
Well, let's talk about some of the newer technologies that are out there. I remember I sat with Secretary Perry, like just before he finished, and I said to him, I said, okay, what's going on with SMRs? When's it going to be commercially viable? And he's like, Andy, 5 years. And I was like, so here we are 5 years later, things have changed. Because you all, DOE does a lot related to SMRs, and you've got experience there. So what do you see as the potential for SMR technology? Not necessarily only for Africa, because that may take a little more time, but do you see a pathway to really commercializing small modular nuclear technology over the next few years?
I do. Look, in the long term, if we wanted to say, how's the world powered, say, 10,000 years from now, it's probably, and most everything I say is wrong, but it's probably nuclear energy, because the huge energy density, a small amount of land, a relatively small amount of materials can produce an immense amount of energy for a long time. The resource is just huge. The other thing key, nuclear today is all in the electricity sector. But it could provide high temperature process heat. It could be used to manufacture fertilizers and plastics and these things we care about. So I think the long run of nuclear is very bright. The technology is there. We developed it quickly here in the United States. And then as governments do with a new technology, it got smothered with regulation and fear mongering. And it's so over-regulated that we continually make it more expensive. And if you make it more expensive, nobody builds anymore. And if you don't build anymore, you don't get innovation. You don't get the benefit of learning, and you don't get to drive the cost curve down. So there's a next generation nuclear technology that we're talking about, small modular reactors. They're even a better technology. They're going to be mostly built in factories. Everything that's built in a factory over the last 20 or 30 years is getting cheaper to build. Everything that's stick-built with people in hard hats putting together hammer and nails out on location, those costs are going up. So we need to move, and a lot of things have to be built that way, but if you can move something into a factory, you can lower the cost of it. So I'm all in on small modular reactors. At DOE, we have programs supporting the test and rollout, the commercial nudge on these reactors. I think they're going to be awesome. But again, in being energy honest or energy sober, this is going to take some time. This is going to take some time. I'm going to push as hard as I can for 4 years. I think certainly in the next decade, we will see small modular reactor out there providing power. And then we got to build a lot of them to get those costs down. But I think they will play a role in Africa. They will probably play a role in remote Alaskan villages. There's a lot of places that will probably never get on the electricity grid. And a lot of people live there. Right? Today, the answer is diesel and solar. You use solar so you burn less diesel, but you have diesel so you have power all the time. Like that's how Hawaii runs. You know, that's not just in Africa. That's everywhere if you're off the grid. But in the long run, I think that will be SMRs. I want it to be as fast as possible.
Right. I mean, look, the labs do great work, and I know that the labs that you all manage, they've supported activities in Africa in the past. I know that at one point they helped Ghana advance West Africa's first of its kind 400 megawatt hydropower plant. They provided support for the Southern Africa Power Pool as well. What role do you see the labs playing in trying to advance this agenda of providing support to Africa?
So 17 national laboratories that are in the portfolio of the Department of Energy, and they are just awesome. This is the biggest producer of Nobel Prizes in the physical sciences on the planet. They started in the Manhattan Project in World War II, a rush to build the atomic bomb before Nazis, who were also working on the same project. And we won that race. It brought World War II to an earlier end. It put the United States in a great position to ultimately prevail in the Cold War. I believe we're entering Manhattan Project 2. Artificial intelligence, and I won't go into detail on it, is going to be transformative in awesomely positive ways. Of course, there'll be negatives too, and I don't know what those are, and I don't know what all the positives are either. But for drug discovery, for new energy technologies, for enabling efficient use of resources, AI is going to be tremendous. We need to, and our labs, one of my charter to our labs is to work with our commercial enterprises on advancements for AI. And AI is a very energy-intensive manufacturing industry. The form of energy it needs is electricity as opposed to process heat. But they work on all sorts of things. And one of my goals, and I think they're all well aware of it, is better energizing the 7 billion people that don't live like us and the 2 billion people that don't even have clean cooking fuels. You will see more work at our lab focused on these challenges, and very passionate, very smart people who want to push forward energy solutions in all different areas. And we want this government, this administration wants to use those resources to partner with all of you in Africa to help on your energy systems, to help better the lives of your citizens. You're right, they are a gem, they are treasures, and there's so many things we can do, but we want to use those resources in partnership with you.
I mean, I'm so glad that you mentioned AI. I've got this other theory that AI and demand for data is actually going to help increase energy access, because when you talk about a lot of these mini grids that are in remote areas, you usually just think of them as just wires going to people's houses. But now with the Starlink connection, they can have other offtake sources of energy. So if you could do localized AI learning, localized data mining, things like that, you can actually reduce the amount of subsidy for mini grids. So I'm hoping we can continue this conversation and take advantage of your expertise to tell us, maybe there are other ways to be thinking about models in the future. So
that's a fantastic point he just made, that you could maybe build a larger scale energy system in a remote community, and the economics would work because you would not just power the community, but that excess energy could be used for AI and realizing value with that by just sending the results out by satellite. Right. Excellent point.
Having distributed data centers, something along that way. So we're looking into this. So we need all ideas to solve this problem. All right, we're out of time. I know we all could sit here probably for 2 hours. This is absolutely fascinating. It's so great to have you here. At the end of June, the Africa Energy Forum is expected to bring about 8,000 people together who are focused on energy in Africa. We're excited about that, and I think all of us will probably be there. We hope that we see you there as well. So thanks so much for taking the time to speak with all of us.
I hope to be there. I hope to be there. Thank you all. It's my honor. My honor.